Hello guys, welcome back. I hope you're all doing great. In today's video, as the name suggests, we will be looking into dynamic memory allocation. We will go through the four main pillars of dynamic memory allocation, which are the malloc, calloc, realloc, and free functions. So let's start. First of all, we need to know when to use dynamic memory allocation. So let's say you're developing a software for a school, and the software records the data of all its students. You as a programmer don't know how many students there are in each classroom, so how will you write efficient code if you don't know how many students there will be in total, or how many new students may join the school later on, or even how many students may leave the school in between? As a programmer, what you're going to do is let the user decide all these minute details. You're going to put a feature in your code which only lets you decide how much memory you need, or lets you decide how much space you need when the code is running. Or you can also say at runtime. This is where dynamic memory allocation comes in. With the help of dynamic memory allocation, teachers who know exactly how many students there are going to be in their classroom can specify the exact amount of space they'll be needing for saving the info of their students. If one teacher required space for say 62 students, then their software lets them specify that when it's running. If another teacher wanted space for only 30 students, then the software lets them do that too. The source code for the software doesn't need to be rewritten for each classroom. Now let's say in the distant future, one of the teachers needed to enter the details of 1,000 new students who get enrolled into their school. Well, the software will even let you do that. So in other words, dynamic memory allocation is used when you, the programmer, don't know exactly how much memory or space you're going to need, so you let the end user do that for you. This is a very simple definition. There are some more advanced features which dynamic memory allocation lets you do. For example, like letting you return a locally declared pointer back to the main function. We will not be going through the advanced stuff in this video. Let's now proceed to the implementation part of dynamic memory allocation. To allocate memory dynamically, you need to include the stdlib.h or standard library header file. I will start with the explanation of malloc or malloc. You can pronounce it however you like. Some people say malloc, some people say malloc. I prefer pronouncing it as malloc. To use malloc, you first need a pointer. So I'm going to declare a pointer to integer and call it ptr. It could be pointer to character, pointer to float, but I choose pointer to integer for, just for this example, for the sake of the example. Next, we can directly use our malloc function. Here we have ptr is equal to int star malloc size of int into num. Alright. This statement asks the operating system to allocate a certain amount of space for the user in the RAM, which is random access memory. And how much memory exactly? The amount of memory is specified by this part over here. Size of, and in brackets, int, multiplied by num. Here num can be taken as an input from the user, or it could be determined based on some calculation in your program. So I need num spaces of memory, and each memory space needs to be of size int. The data type of integer takes up different amounts of space in different systems. So whatever integer takes up in my system, that multiplied with num. And that is how much memory I need. So my operating system gets me num multiplied by size of int bytes of contiguous memory and saves the starting address of that contiguous memory into ptr. You may be wondering why I chose size of integer. I chose size of integer because the pointer I'm saving the starting address to is pointer to integer. Next, this int star over here means that we are typecasting whatever malloc returns to pointer to integer. By default, malloc returns a void pointer, and once again, since I'm initializing ptr, which is a pointer to integer, I'm also going to typecast my malloc to type pointer to integer. Note that this typecasting step is not compulsory. We do it because it is a good practice and also because it ensures compatibility with C++. So now what happens if we ask for memory but there isn't enough in our heap? Heap memory is part of the RAM, and it is from there that dynamically allocated memory is taken. So in such cases, when there isn't enough memory allocation fails, and malloc returns a null. So when we use malloc in our code, we should also check if the pointer we initialized with malloc is a null. If it is null, then memory allocation has failed. Finally, always remember that dynamically allocated memory can only be accessed through pointers. Here PTR points to the first byte of the allocated memory, and using pointer arithmetic, we can access the subsequent bytes. Moving on to the calloc function. PTR is equal to, first of all, I'm going to typecast it to int star, calloc of num, comma, size of int, alright? There are only two differences the calloc function has with malloc. So the first difference is with the parameters that are being passed. As you can see here, calloc takes two arguments. The first one is the number of blocks of memory that you'll be needing, and the second argument, which is separated by a comma, specifies the size of each block that you'll need. So in our example over here, I'll be needing num blocks of memory, and each of the block will be of size integer. This is equivalent to what we wrote previously for the malloc function. The other difference between malloc and calloc is that the memory that gets allocated with malloc doesn't get initialized, whereas the memory that gets allocated with calloc gets initialized with 0. Because of this, calloc has a slight overhead compared to malloc, as the system not only needs to allocate memory, but also now has to initialize all the memory spaces with a 0. Finally, just like malloc, you also need to check if calloc is equal to null, in case of a failure in memory allocation. Now let's move on to realloc. To explain the realloc function, let's revisit our previous example. Imagine it's the start of a new school year and a few students left the school while a few more students joined. To add the details of the new students, we need to make a few changes in our software. The function is provided, which reallocates memory for the additional students who may have joined the school in the new academic year. Let's say 10 new students join the school. If our software previously allowed us to save the details of 62 students, we now have to reallocate an additional 10 spaces for the 10 new students. Also, we need to do this without losing the info of the previously saved data. So as you can see over here, the realloc function takes two arguments. The first argument is the pointer we wish to reallocate memory to. And the second argument is the new size we want our pointer to hold after reallocation. You should note that the new size we allocate our pointer to may be larger or smaller than the previous size. If it is smaller than the previous size, then it will lead to data loss. However, if the new size is larger, then the starting address of the pointer is kept the same. The additional bytes of memory are added at the end. Sometimes when we ask for a new larger space of memory, what happens is the operating system might not be able to give us an entire contiguous block which starts from our previous starting address. In such cases, the operating system allocates a new starting address in memory from where we now are capable of saving all our data. The new starting pointer is allocated in such a way that we'll be able to save our old data and the new data in a contiguous manner. Similar to malloc and calloc, if there is no space at all for memory allocation, then realloc also will return a null, and the old data will remain as it is unchanged. And now a fun exercise for you guys to do. What do you think will happen if I use the realloc function for a null pointer as shown in the example below? Comment below what you think will happen. The last function we'll be discussing is the free function. In the code snippet shown, the free function frees the allocated memory and gives it back to the operating system. Once our program or software is done using the allocated memory, or once a program has reached the end, it is our responsibility to free the allocated memory. This is done so that the memory space can be reused by other processes that may be working in your system. Note that we won't get any errors even if you don't use the free function. This is because the memory space that is allocated dynamically always gets terminated automatically when the program ends. That being said, it is always a good practice to use a free function when we are done using the pointer. This helps avoid any memory leaks that may occur while a program is running. I'll be explaining the concept of memory leak in another video. For now, all you need to know is that you should always make it a point to free the pointer which you used for dynamic memory allocation once you're done using it. that will be all for today's video. I hope you guys understood. If this video was of any help to you guys, please do consider giving it a like, as that helps support me and the channel. Please do also consider subscribing if you wish to get more such content on programming. Alright guys, so take care. I'll see you guys in the next video.